So for number 1, it says to find the inverse and to graph it by hand. So I know if it goes to the point -1 1/3, I know it'll be at 1/3 -1, and at 1 0, and at 3 1. Okay, so my graph will look like this. Okay, then it says to find the domain, which will be x is greater than 0. The range, okay, goes up, keeps going down, so all real numbers. Whether it increases or decreases, so it's increasing. It doesn't increase over here, but it's increasing for all of its domains, so from zero through infinity. Okay. What else does it say? Vertical asymptote. Okay, the equation of the vertical asymptote is right here at x equals 0. Okay, number 7 says for each function, if f is an exponential function, the inverse f of x, oops, you can't see the problem there. The inverse f of x would be a logarithmic function. Okay, so they are inverses of each other. Okay, number 10, log of 1/2 x. Remember, if it's just log, it means it's base 10. Okay, but I want you to graph this on Desmos and look at the graph and see what that looks like to find its domain. Okay, so by looking on Desmos, this is what these look like. So the domain here goes from, there's an asymptote right here, right? So from 0 through infinity. Here, domain goes from here to 0, so from -infinity to 0. This one here goes all the way this way, all the way this way, so it would be from -infinity to +infinity, where you can write it as all real numbers. And this one here will keep going down, right? Keep going out and out, so from -infinity to +infinity, which is also all real numbers. I was just incorrect when I said this in number 16. Okay, number 16, if you had set this equal to 0, right? Take a -1 through and you get x plus 4 and x minus 4. We actually have asymptotes at 4 and -4, so they won't actually go through there. So the correct answer actually should be from -4 to 4. Okay. Okay, look at this. If you would take this and factor it, you would have 2x plus 1 and x minus 4. So I have asymptotes at 4 and at -1/2. Okay, so my domain would go from -infinity to -1/2, and then also from 4 through infinity. Okay, if I take this and solve it, I get 0 and 9 and -9, because if you take an x out first, you get this, right? And then you factor this, you get 3 and -3. So so we have asymptotes here at -9, at 0, and then also here at 9. We have the graph out here as well. Okay, so our domain goes from -9 to 0, and then also from 9 through infinity. Okay, so by looking at Desmos, that really helps us to decide some things here. Okay, number 31, etc. We want to just look at these and thinking about what's happening to them. Okay, so we're taking our base function. It's an exponential with a base of 2 point whatever, so it's exponential growth, and we're shifting it up 3. Okay, so you can see here we're shifting it up 3, so 31 is B. 32, once again, it's exponential growth. Okay, E, remember, was, let me move that over. Remember, E was 2.7 whatever, and if it's above 1, it's exponential growth. -3 shifts it down 3. So you can see it shifted down 3, so G. Okay, E, okay, it's exponential growth again, and it's shifting to the left 3. Okay, so yeah, we can't really see that too much there, but that one's D. I wish they would show you that where 1 is, sort of idea. But this one here, it's shifting to the right 3. So F, like this one here, see how you can see Usually it goes through 1. You see how it shifted to the right 3? Okay, so that's what I like how that one is better. Okay. Number 35, our natural log means it's base e again, but it gets shifted to the up 3, so you got your choice. Okay, so 35, I think we were here. I went to help another student. But anyway, we know it's the natural log. It's a log base e, which is a natural log, and it's being shifted to the right 3. Okay, so you can see here being shifted to the, sorry, it would go through here, right? I'm sorry, up 3, right? Up 3, not to the right or left. Right or left would be inside the parentheses. This would be up 3. So generally it goes through 1 here. It would go through here like this, but it's being shifted up 3. Okay, so 35 is A. 36, okay, we got the same thing, but it's now being shifted down 3. So instead of going through here at 1, it's being shifted down here, going through at -3 there. Okay, this is being shifted to the right 3. So you can see the asymptote is usually at 0. It's being shifted over here to the right 3. And the last one here is being shifted to the left 3. So you can see it being shifted left 3 here. Okay, these last 3, we're going to just find the inverse, okay, analytically, so just solve for the inverse. So remember we switched the x and the y, so this y becomes the x, this x becomes a y. Okay, now I got to solve for y. So I'm going to have to add your 3 to the other side, and then I have to write it as a log. Okay, so I know that log base 4 of x plus 3 equals the y. And another way to write that y is the f of negative x, right? F of -1. Okay. This one here, once again, we switch the x and the y. So x is equal to 1/2 of y to the negative y to the y -5. First thing, we're going to add that over. Okay, and I take the log function again. So log base 1/2 of the x plus 5 equals the y, or the f inverse. Number 59, x equals -10 to the y plus 4. Add your 4 over, subtract your 4 over. Get rid of your negative here. So it'd be a -x and a +4 when I divide by negative. And turn this to a function, the log function. So it's log base 10, but log base 10 we don't need to write the 10 there, of -x plus 4 equals the y. Okay, switch the x and the y. Subtract your 6 over. Get rid of the negative. Okay, and remember log base e, okay, we don't really write it like that, we write it as the natural log, right? It's the same thing, okay, but just, okay, log base e of -x plus 6 equals the y. Same idea, but we always put natural log instead of log base e. Okay, there's the homework. Come to class with any questions.